Hey there, welcome back to lesson 2C-3, part 1, where we are solving logarithmic equations. In the first video, we solved logarithmic equations where we had to condense logarithms on one side of the equation, and our other side of the equation was equal to a number. We're going to start to look at examples where we have logarithms on both sides of the equation. How do we go ahead and solve that? So, just to remind you again, you have to be successful, or in order to be successful, you have to know the properties of logarithms in order to change the structure. You have to be able to solve linear and quadratic equations, as well as determine if a solution is valid or not. Remember that our argument must be positive. So we plug it back in. If it's 0 or negative, we throw it out. We're mainly going to go ahead and focus again on the structure of the equation where we have a logarithm on both sides. So really here, this part A, if I have a log on both sides, if they're both equal to the same logarithm, we can cancel that logarithm. So really, it's pretty intuitive. Let's go ahead and jump into our first example. The function f is given by f of x equals log base 2 of x plus 4 plus log base 2 of x minus 2. The function g is given by g of x equals log base 2 of 3x plus 4. In the xy plane, what are all coordinates of the x coordinates of the points of intersection of f and g? So what they want here is they want f of x to be equal to g of x. So we're just going to go ahead and we're going to set these logarithms equal to each other. Log base 2 of x plus 4 plus log base 2 of x minus 2. And I want this to be equal to the other function g of x, which is log base 2 of 3x plus 4. Okay, so what we're going to have to do is we're going to have to condense this right side. I have two logarithms. I want one logarithm on each side. So this is going to end up becoming log base 2 of x plus 4 times x minus 2, which is equal to log base 2 of 3x plus 4. Now, you can go ahead and interchange these next steps. You can multiply this out into a trinomial, or we can just go ahead and use the property of equality. This is the logarithmic property of equality. I have two logarithms that are equal to each other, therefore their arguments must be equal to each other. And so this gives me x squared plus 2x minus 8, which is equal to our right side 3x plus 4. I just went ahead and I did both steps in once, right? I just multiplied this out. Okay, and now I have an equation. This is a quadratic equation. How do we solve it? Well, I need to move everything to one side. I need to set this equal to 0, so we'll subtract 3x and we'll subtract 4, and let's see what we get. X squared minus x minus 12 equals 0. So it looks like we have x minus 4, x plus 3, which is going to give us two zeros. I'm going to get a positive 4 and a negative 3. Okay, so which of these are we going to keep? Well, we got to check. Does it make our argument negative? So let's check 4. 4 plus 4, 8. We're good. 4 minus 2, 2. We're good. Okay, negative 3. Let's plug this in. I get a positive 1. We're good. Negative 3 minus 2. Oh, that is negative. Oh my gosh, this one is extraneous or not valid. Okay, so x equals 4 is our solution. All right, here is the next practice one. Please go ahead, pause video. I want you guys to try this one, and then I'll show you the answers. All right, so here is our solution here. They want the intersection of r of x and p of x. So we'll set them equal to each other. Here's r of x. I can go ahead and use the power property. I'm going to move this 2 up to give me 2 squared, which is 4. So log base 6 of 2 to the second gives me the 4. And I also use the product property to multiply with the argument. So I get log base 6 of 4x on the left. On the right-hand side, we can combine these again with the product property, and you got x plus 9 times x minus 2, which after distributing would give you x squared plus 7x minus 18. Since I have a logarithm on both sides, I can use the property of equality. These cancel. And so what we end up getting is 4x equals x squared plus 7x minus 18. Move the 4x over via subtraction, and then I can factor this to be x plus 6, x minus 3. Now the solutions will be the opposite, x equals -6 and 3. And when we plug in -6, oh, I have an argument here that's just x. So any negative value is going to be thrown out. Okay, the solution here is 3. 3 came close, by the way. If you plug in 3 minus 2, that's 1. So very close there, but we're good. All right, let's look at the last example for this lesson. Find all values for which 2 log 10 base 10 of x minus log base 10 of x plus 12 is equal to log base 10 of 2. So they give us the equation very, very straight up. So I have 2 log 10 of x minus log 10 of x plus 12 equals log 10 of 2. So I'm going to go ahead and use the power property first. This gives me x squared. And then I'm going to use the quotient property. So we get log base 10 of x squared over x plus 12. And on the right hand side we just have our common log of 2. Log base 10 of 2. Okay, a single logarithm on both sides, so what can I do? I can cancel them. They can cancel. So we get the equation x squared over x plus 12 is equal to 2. Now I'm going to go ahead and solve this by multiplying by x plus 12 on each side. That'll cancel the denominator. And what we get is x squared equals 2 times x plus 12, which on the right hand side that'll be 2x plus 24. Now this is quadratic. I need to move everything to one side. So what side do I want to pick? Well, you want to keep your leading term positive. So I like to move everything over to the left. So I get 2x, a negative 24 equals 0. And now I can factor. So x, what are we looking for? 6 and 4, I think. Minus 6 plus 4. And so I have two solutions, 6 and negative 4. Am I going to keep any of these? Yep, it looks like we'll keep the 6, the negative 4. I have log 10 of x. So that one's got to go away right away. So x equals 6 is our solution. Okay, I do have a practice problem, last one for you here. Go ahead, pause me, I'll show you the solution. Okay, hopefully you got this answer, 5. We condense our left-hand side of the equation into a single logarithm, 2x divided by x minus 3, because that is subtraction, so we use the quotient property. Now that we have a single logarithm on each side, we can cancel the logarithms, and we get 2x over x minus 3 is equal to 5. I'm going to get rid of that x minus 3 in the denominator by multiplying, and so what you get is 2x equals 5 times x minus 3. We'll distribute, and then we'll go ahead and move our 5x. I subtracted 5x here on each side, and then I divided by a negative 3 in order to get x equals positive 5. It is valid. When you plug in 5, everything is peachy. Okay? Did you learn how to solve logarithms in this video? Hopefully you did. Give me a thumbs up. I'll catch you in the next video where we again solve some more logarithms with different methods. Catch you later.